Okay, so today we're going to continue our graphing of sine and cosine with adding in more of our transformations altogether. So yesterday we mostly focused on horizontal, vertical, and amplitude shifts. We did do a little bit with our period change, but today we're going to look more at the period change mixed with other things, so that way we can get more practice at that. So we're going to go through two examples here, and then I have one more that we're going to do in class before you start your notes to make sure we've clarified any questions that are still remaining. So the first example I want to do with you guys is to graph y equals negative sine and 3x plus pi in parentheses with the plus 1 on the outside. So just like in the last few from the other day, I'm going to make a list of all my transformations so that I can get an idea as to how to do my graph. Because again, all these graphs, both sine and cosine, follow a pattern. So if we follow that pattern but just apply our transformations, we don't always need to make that table of values. So in looking at this problem, my amplitude, which is the number in front, is 1. So that means from whatever my vertical shift is, I'm going to count up 1 and down 1 for my highest and lowest points. Now this negative, that negative isn't one of our terms here, but what it does tell us, and if you want to write this at the bottom, you're going to start down instead of up. Because normally sines, we start at 0 and go up, and now we're going to start at 0 and go down because of that negative. Okay, so when it comes to our vertical shift, we look for the number being added or subtracted outside. So that would be 1. So we're going to go up 1. Now the horizontal shift. The problem right now with our horizontal shift is that we have this, it's not in the right form. So for our horizontal shift, this needs to be x plus or minus something. This 3 here is throwing it off. So if we take the 3 and factor it out, this will become 3 times and then x plus. So remember, when we factor something out, it's like we're dividing every term by it. So this would become pi over 3. So in looking at our horizontal shift, we're going to be shifting to the left pi over 3. And then for our period, our b term is this one right here. So when we go to find our period, we do our 2 pi divided by 3, which means the entire length of our graph from start to finish will be a length of 2 pi over 3. Okay, so these are all of our transformations. So now when we go to actually apply them to the graph, we're going to start with the labeling. So I know I have a vertical shift up 1. So that means I'm going to have my new horizontal axis right here. So if my amplitude has to go up 1 and down 1, then my graph has to be able to go up to 2 and down to 0. So there's my x or my y-axis. For the x-axis, I need to start by moving my starting point from 0 to pi over 3 to the left. So I'm going to go negative pi over 3. Now from my start point to my end point, I have to go a total of 2 pi over 3. So this is 1 pi over 3, 2 pi over 3. So there's where I'm going to end. So my period has been significantly shrunk down. So we still have to find those middle points, our key points that we would use for our graph. So we have our first key point, our last key point. The middle of these two is 0. We have that one there, it's our origin. But we do have to find our other halfway points to get the rest of our key points. So we have to think, what's halfway between negative pi over 3 and 0? So if you add those together and divide by 2, you'd get negative pi over 6. What's halfway between 0 and pi over 3? Positive pi over 6. So these will be our key points for our graph. So again, how we got these, our start was where our horizontal shift took us. Our end, we count from this start point what our period is. So we go from our horizontal shift, add 2 pi. And then we find our key points by finding the halfway between start and finish. And then we find the halfway between the start and the middle, and halfway between the middle and the end. So now what it comes down to is following the pattern and plotting the points. So sine graphs we know start at 0. So I'm going to start at my horizontal. Then because of the negative, so I'm coming back down to my reminder here, I go down instead of up. So I'm going to go down 1. My middle will be back at 0. Then I'll go up 1 and I end back at my vertical shift of 0. Connect the dots and you have your sine graph. Okay, so a lot of this is going to be remembering your pattern. Sorry, this is going to bug me. So that way you can just use your transformations rather than your table of values. If you wanted to use a table of values on all of this, you could. It just means knowing your transformations isn't necessary. But when you know your transformations, it makes graphing a lot quicker than making that table every single time. So some of the questions that you're going to be asked about the graph. A question you might be asked is, where is the max? So where is your highest point? You would say your highest point where would be at x equals pi over 6. What is the max? Means what is the actual value? That would be 2. So the where is the x, the what is the y. So we know that our highest point will be at 2, and we'll get that at pi over 6, at least in the one we drew. Obviously this continues on forever, so we'll have maxes occurring every 2 pi over 3 from the pi over 6. Another question would be, what is the minimum and where does that occur? So for minimum, what is the minimum? Your minimum is 0. Where does that occur? At x equals negative pi over 6. Okay, so these are some questions that you could be asked about a graph, and you'll need to know the difference between what and where and which value it's actually talking about. And we're going to go over more of these questions on our in-class example as well. Alright, so let's do our second example. This one's going to be, again, we're going to stick with sine graphs right now. Tomorrow, I believe we'll do a cosine in class. So we'll do y equals 3 times sine of x over 2 plus 1. So just like in the one before, I'm going to list out my transformations so that I can know what I have to do. So amplitude, again, comes from the number being multiplied in front. So that means my amplitude is 3. My vertical shift will come from the number being added or subtracted outside. So here we'll have a vertical shift of up 1. Now the horizontal shift comes from being added or subtracted inside the sign. Here we don't have anything inside of our sign function being added or subtracted, so that means we don't have a horizontal shift. So you can either write the null set or you can write none. Either one would be fine. Lastly, we have our period. So we have to look at what number is being multiplied to x. So if you think of this as 1/2 times x, your b, so we have 2 pi divided by 1/2. Well, when we simplify that, what's 2 pi divided by 1/2? We can change it to 2 pi times the reciprocal of 1/2, which means our period is actually 4 pi. So we don't have any negatives, so we don't have that little note to ourselves about starting down first. We can go ahead and start with our graph because we've got all of our necessary information. So again, I'm going to start with my x and y axis. I know I have a vertical shift of 1, and I have to be able to do an amplitude of 3, meaning I need to be able to go 3 in either direction. So if my vertical shift of up 1 takes me here, I have to be able to go up 3 and down 3 as well. So I'm going to make sure my graph can cover that. So that means I'll be at 4, and down here I'll be at -2. So I'm going to label my high and lows. Next up, I need to figure out my period and my starting point for my x-axis. Because there was no horizontal shift, I can start at 0, where I normally start. But my period has to go for a total of 4 pi. So that means I'm going to end all the way over here at 4 pi. So then what's halfway between 0 and 4 pi? 2 pi. What's halfway between 0 and 2 pi? Pi. And halfway between 2 pi and 4 pi is 3 pi. So we find our 5 key x values, and again we make sure we label them. So now I can go ahead, I've got my graph marked, I know my pattern, I can go ahead and now graph based on the pattern and my key points that I have. So I can start at 0, and again I'm starting at my new horizontal, my vertical shift, which I drew by the dotted line. So I can start at 0, and I'm going to go up first since I didn't have the negative like the last one. So at pi I'm going to be up 3 at my highest point. At 2 pi in the middle I'm going to be back at my horizontal. Then at 3 pi I'll be at my lowest point, down 3. And then at 4 pi, I'll be back at my horizontal. Connect the dots, and you have your transformed sine graph. So this one was stretched, so that way it went over a longer period of time. So again, you could have the same kind of questions. What is your maximum? Where does it occur? What is your minimum? Where does that occur? So in this case, we would say our maximum occurs at pi and has a value of 4, or you could say it as the what and the where. So your where does the minimum occur? At pi. What is the minimum? Actually, maximum. Your maximum occurs at pi, and where is it? It is at, or what is it? It's at 4. So tomorrow we're going to be focusing on these two types where we're putting all of our transformations into one problem. So within one graph you could have something on each one of these lines like we did in the first one. And again, the key is going to be making sure your graph is labeled and marked so that we can just follow the pattern. Okay, so like I said, we're going to do one more tomorrow. I'll make it a cosine graph that has many of these so that we know what to do when we have different combinations.